Hello friends, welcome to my channel. In this video, we are going to see important points in digital electronics. That is nothing but DLD and STLD subject itself. Let us come to the point. First, let us see the difference between analog systems and digital systems. Analog system uses continuous signals to represent information. But coming to the digital systems uses discrete signals to represent information. You can observe the signal itself. It is a continuous in nature and it is a discrete in nature. So here the same information, it is sampled like this. Now, analog systems hardware are not flexible and the digital systems hardware can be easily modulated, hence it is flexible. Let us see the examples, analog systems and the digital systems. Now this is the analog clock and voltmeter. This is the digital clock and a digital multimeter. Let us see some more points. Analog systems are more affected by noise. Digital systems are less affected by noise. In analog system, data stored in the form of wave signal. In digital systems, data stored in the form of binary bit. In analog system, data transmission requires less bandwidth, but in digital system, data transmission requires more bandwidth. This is the only drawback in digital system. Well, here the comparison. Next, analog system consume more power than digital system. Digital system consume negligible power, very less power. Next, analog signals are less reliable because analog signal degrade over distance and must be amplified. And the digital signals are more reliable way to encode and transmit information. Hence, we can say that analog systems are less reliable and the digital systems are more reliable. The overview points you can observe. So these are some advantages in digital system. Like digital systems are less affected by noise, flexible hardware, and we can store the data easily, and consumes less power and more reliable. Now let us come to the limitations of this digital system. Okay, advantages are more compared to analog system. Then what are the limitations? The real world in mainly analog itself. For example, if you consider my voice signal, it is analog in nature. Okay, so to deal with these analog inputs, 3 steps must be followed. The first step it is convert the real world analog inputs to digital form and process the digital information, whatever it may be, this digital data we are going to process, then convert the digital output back to analog form. Okay, so these are the 3 points we need to remember, limitations of this digital system. Next, duality theorem. Duality theorem says that starting with a Boolean relation, and you can derive another Boolean relation by changing these signs. That means, let us consider the example, the distributive law A into B plus C, which is equal to AB plus AC. Now I am using these properties, changing R sign to undersign, and changing undersign to R sign, and logic 0 to logic 1. Now R means plus symbol and under means multiplication symbol, we know that. So here A into B plus C. So it is converted with the help of this duality property. So A plus and B plus C, it is plus symbol, it is changed to multiplication symbol. That means B into C. That is equal to A into B, it is changed to A plus B, plus is converted to multiplication, and AC, which is converted to A plus C. So this is the duality theorem. And here, very important point, whenever the complement variable is there, do not change that complement variable. Next, De Morgan theorem. Two important properties are there. The first point, it is A into B whole bar, which is equal to A bar plus B bar, and A plus B whole bar, which is equals to A bar into B bar. Next, consensus theorem. AB plus A bar C plus BC, which is equals to AB plus A bar C. So where BC is the redundant term. Next, combination circuit, the definition. Then what are the examples of this combination circuits? So decoder, encoder, multiplexer, and demultiplexer, and comparator. Not only this, apart from that, like adders and subtractors are also there. Next, let us see the definition of this decoder. It is a combination circuit. It activates output corresponding to the input binary. The types of decoders: 2x4 decoder, 3 to 8 decoder, 4 to 16 decoder, etc. Next, encoder. It is a combination circuit. It performs the inverse operation of a decoder. In encoder, the output lines generate the binary code. Output lines generate the binary code corresponding to the input value. So this is important point. So types of encoder, it is nothing but 4x2 encoder, 8x3 encoder, 16x4 encoder, etc. Not only these, some other types are also there according to the application point of view. So that we will discuss later. Next, multiplexer. Simply we are called as mux. So it is having many inputs and single outputs. In simple way, we can say like that. It has many data inputs and single output depending on control or select inputs. This is important point also. Types of multiplexer: 2x1, 4x1, 16x1 mux. Next, demultiplexer. It is a data distributor. We can also call it as a data distributor. It takes a single input and gives several outputs, like types 1x2, 1x4, 1x16, demux, etc. Next, comparator. So it is just comparing the input values, present input. For example, a digital comparator or magnitude comparator is a hardware electronic device that takes two numbers as input in binary form, for example, 1s and 0, and it determines whether the number is greater than, less than, or equal to the other number. Let us consider here A and B are the inputs, and the outputs are nothing but A greater than B, A less than B, or A equal to B. So it is just like a 2-bit comparator. So these are the some points, and we are going to see some more points in the next video. I hope you understand this. Thank you for watching this.